In this video, we're going to look at chord segments. So I have one chord in this diagram in red, and of course a chord has its endpoints on the circumference of the circle, and then the other one in blue. So when they intersect inside the circle, they divide each other into two parts. So the chord in red is two parts, A and B in red. So it goes from the endpoint here to where they cross. That's A right there. And then the other part for that particular chord is B. It goes from that point to the other side. In the same way, the chord in blue, one part of the chord is part C here. It goes from the endpoint to where they cross. And then the other part for that one is D. It goes again from the point of intersection to the circumference. And there's a theorem we want to look at. Certain properties of this situation that happens because of the symmetry that a circle has. So this theorem states if two chords intersect in a circle, the products of each chord's segments are equal. So that tells me then that this part A, whatever that length is, and here these are links. The A, the B, the C, and the D represent links. A, B, C, and D. So it's telling me that the product of A and B will always equal to the product of the other two parts for the other chord, C times D. No matter where I draw the circles, as long as the intersection of the two chords, wherever I draw the chords, this property is going to hold according to this theorem, as long as the chords intersect inside the circle. So let's suppose we have a situation where let's let A equal to 2. So this length here is 2 units, and this one over here, the second part of that particular chord, is 6. And then for the other chord, let's say for the part C, say that's equal to 3. And let's say D is unknown. Let that equal to Y. The problem is to find the value of Y. Okay, so we know what has to happen. We know the parts. For the chord in red, the two parts are 2 and 6. So that product, 2 times 6, has to equal to the product for the parts belonging to the other chord. So that would be 3 times Y. So using this theorem to find Y, all we're doing then is solving an equation. 2 times 6 is 12. Solving for Y, so isolate the variable, divide by 3. Let's cancel out. Y equal to 12 divided by 3 is 4. And now here we're dealing with links. It's not degrees or anything like that. It's length. Didn't give any units, so it'll be 4 units. That could be inches, that could be feet, whatever. We just say, let's just say Y equal to 4 units. So we use geometry, and then we incorporate algebra to solve what they're asking for. In this case, it was the unknown. Now, before I go to the next one, I do want to point out to you is sometimes they'll give you the length of the whole chord. So let's suppose they tell you that the chord in red has a length of 9. Okay, the chord in red has a length of 9, and say they give you the parts for the other chord, and they want you to find the length of part B. Then you would simply say, okay, let's let part B equal to X. Okay, part B is X. And if they tell you that the length of the whole chord is 9, then you know that because they have to add up, the two parts have to add up to the total, 9 minus X. So then you would just say, okay, A is equal to 9 minus X. And let's say you were given C and D. Then you would just say, okay, 9 minus X times X, forgive me, 9X minus X squared is equal to whatever the product of the other two is, and then you would solve the equation. Now in that case, you would solve a quadratic equation. But that's what you'll do. If they don't give you the individual parts, they might just give you the length of the chord and ask you to find one part of it, A or B, in this case X. That's your setup. And I'm going to do something like that in the next one here. So let's suppose, on this one, let's suppose that this is given to be X. I have two chords intersecting, and they give me this part right here to be X. And let's say C is equal to X plus 8. And let's say for the chord in red, they give you the length of A to be 5. And they give you the length of B to be X plus 2. And here they want you to find the length. So we want to find the length of the shorter chord. Now notice some of these are given in terms of X. So in order to do that, we have to solve it again, solve the equation for X. So let's set it up. If you look at the chord in blue, its parts are X plus 8 and X. So according to the theorem, that product should equal to the product of the other chord in red. Okay, so X plus 8 times X, or X times X plus 8, same thing. And then for the other one, the parts are 5 and X plus 2. So now we got to solve this equation. In order to answer what they want, find the length of the shorter chord, we need to solve this equation. Let's distribute here, multiply through with X. So x times x is x squared, and then x times 8 is 8x. And then on the right side, distribute the 5. 5 times x is 5x. 5 times 2 is 10. And then we want to isolate the variable. Now here since I have an x squared, and I want to get my terms on one side. Sometimes the square will cancel and you'll just have a linear equation. But here it's not going to cancel. So let's just say, let's add a minus 5x to this side and a minus 5x to this side. Anytime you have a quadratic x with a square on it, you want one side to be 0. So I'm going to add minus 10 over here. So I'm bringing everything over to the left side. Short way to do that is just bring them over, change the sign. So let me put it over here. So this will give me x squared minus 5x and 8x is a plus 3x. And then over here the minus 5x cancels. 5x and a minus 5x and a 10 and a minus 10 cancel. And of course the minus 10 comes over. And then the right side is just 0 now. Once you have everything simplified and one side is 0, then you proceed to factor this. So since the coefficient of the square term is 1, we're looking for factors of minus 10 that multiply to give you negative 10, but add up to 3x. So that'll be 5 and negative 2. 5 times negative 2 is 10. 5 and negative 2 is 3. So that's what we want. So we just make this x plus 5 and x minus 2. This is equal to 0. So once you have it factored out, and one side is 0, we have a product of two factors equal to 0. The only way that can happen is if one of the factors or both factors are 0. So we simply set each factor equal to 0. X plus 5 can be 0, or x minus 2 can be 0. So here we get isolate the variable, so we need to get rid of the 5, take it over and it becomes a negative 5. The same thing as adding negative 5 to both sides, and we get x equal to negative 5. Here we add 2 to both sides, we get x equal to 2. Now here we're dealing with lengths. Can't have a negative length, so this answer we have to reject. X cannot be negative 5. We throw that one away. The only possibility is x equal to 2, okay? And some of these problems like this, they might just give you this information and they might just say, find the value of x. So in this case, you would finish right here. You say, okay, the value of x is x equal to 2. But here it says, find the length of the shorter chord. Find the length of the shorter chord. So in order to do that, we need x to be, we need to plug in 2 for x. So let's look at this one right here, the one in blue. So 2 and 8 is 10, and 2 more is 12. X is 2. Okay, x plus 8, this chord is made up by the segment x plus 8 and x. So x is 2. So 2 and 8 is 10, and 2 more is 12. And then for the other one, the one in red, part A is 5, 5 and x is 2. So this is B, part B is 2 and 2 is 4. So that would be 5 plus 4. So that's 9. And that's your answer because it says find the length of the shorter chord. The one in blue is 12 units. Over here, this part is 5, and then this one is x plus 2, but x is 2. So this is 4, and 5 is 9. So the shorter chord is 9 units. Thanks for watching. We'll see you next time.